Hello everyone, and welcome to another episode in our Hackerlate tutorial. Today we're going to be talking about a very specific new technology that Hackerlate Studio is supporting, which is the support of Oracle 23c's Duality Views capability. There's a really great introduction that Oracle has posted quite some time ago actually, around introducing this new kind of way of working with documents inside a relational database system like Oracle. They call this the document relational duality, right? Which is basically trying to achieve, and there's a really great video about this, to get the benefits of both worlds, right? Both the denormalized way of working with JSON documents and the normalized way of working with relational systems, right? Both have their pros and cons, and obviously what Oracle is trying to enable here is to combine the best of both worlds in the same system. So that is actually what they are providing with the JSON document relational duality capability, where in the relational system, data is actually being stored as rows in tables. This obviously has many advantages, for example, transactional capabilities and everything else, SQL access, those types of things, right? So that's how you store the data, but you can access the data in a different way through JSON documents. This obviously delivers a lot of simplicity to the application, right? Because this is the power of NoSQL. This is what application developers have grown to love. In a duality view, Oracle, therefore, tries to combine the best of both worlds in the same system. A duality view exposes the data in the relational tables as JSON documents. The concept of this is actually not very new, right? This is very similar to what has been done before with object relational mappers. This is something that many application developers will know as a layer that they use from their application to expose the complexity of the relational system as objects. It's very different from object relational mappings in the sense that object relational mappings typically live on the client side, right? They typically live inside the application that you are developing, right? That's where the mapping is actually happening. With the duality views, Oracle is actually bringing this to the server. The server, the database server, is going to offer the object view as a JSON document, as a mapping to the relational system underneath it. Therefore, both server-side and client-side applications will be able to use it. In Hackerlate Studio, we've actually developed our support for this system inside the Oracle plugin. We've adapted the Oracle plugin to support the modeling of duality views. And yes, you do still need to model. You do still need to know what the data structure looks like inside these duality views, and you need to be able to document it, you need to be able to govern it, you need to be able to work with it in a productive way. A duality view, therefore, is a special kind of view with properties and columns, but also the capability of having nested objects of a special kind inside the view. It also has a specific type of syntax, right, which combines a new vocabulary and a new structure that obviously our tool also needs to understand, both in the forward engineering capabilities and in the reverse engineering capabilities. Oracle also provides examples that you can take a look at, and there's a repo that you can access where you can find some of this information to get yourself familiar with it. The case that we would like to work with, and we'll come back to this in the demo a little bit later on, is based on a very specific use case around car racing. And you will see this quite immediately, because obviously there are two ways of creating a model from this system. And one way of doing that is to start from the DDL, the data definition language file, which is provided by Oracle, and then you reverse engineer this into Hackerlate and you receive the relational tables and the duality views inside your data model. Now, you will see that it doesn't expose everything yet, right? The DDL actually doesn't give you any insight into what the nested structures potentially might look like inside your duality view. Podium, for example, it doesn't expose the structure of what the podium will look like. However, if we actually do the reverse engineering in the alternative way by connecting to a database system that actually has the DDL executed and that also has some data inserted into it, then we will quickly see that the system is actually a little bit more refined. The podium object that we had defined in the DDL now has been inflated, so to speak, and you will actually see that the podium actually has the first runner-up, the second runner-up, and the winner as the different nested structures inside it. Both in the relational table and in the duality view, this is actually something a little bit more sophisticated. Our database reverse engineering will automatically detect this. Why? Because we do probabilistic sampling of the database, and this will obviously also understand that the structure is more refined. Hackalate will also allow you to generate or understand or reverse engineer, forward engineer the syntax, the SQL syntax for these duality views. Note that there is an alternative way of doing this using GraphQL, but this is currently not yet supported. Creating a duality view is super easy inside Hackalate using our tools capability. You can just add a view, indicate that it's a duality view, add a few specifics, and then all you need to do is first select the columns. If you straight up want to import a number of columns from a root table, then you can do that super easily by selecting them. And then next, of course, you can add a nested, or as we will see in a little bit later, an unnested structure inside the duality view. This is how you see the heart of the power of the duality views, because it effectively represents a join structure that is being executed over the rest of the relational tables. A subquery will be run, and that subquery will populate the JSON object that you are representing inside this duality view. Right? So this is super powerful. You can have these subqueries added as attributes of your duality views, both in a nested field or in an unnested field, as your application might require it. Last but not least, Hackalate also supports the forward engineering of the model that you have designed in this way to a DDL script, using the appropriate syntax, using everything that you should have in order to have this implemented inside your Oracle database. So with that, why don't we take a look at this and we can see what this looks like inside the Hackalate Studio. So let's take a look. Let's take a look at these Oracle 23c duality views. You should obviously take a look at our manual page, right, which is very elaborate, lots of information over here, lots of links. And you will also see that there are some links here to the Oracle developer guides and sample repos, right? So I have that right here. This is the developer guide, and this is the repo that contains the DDL that is actually going to implement duality views in a sample database. Note that this DDL is actually not just the DDL, it also contains some data here at the bottom, right? So where you can actually insert data, over here, right? You can insert values into the database and play around with that. So what we're going to do now is we're going to spin up our Hackalate Studio, and we are going to create a new model for an Oracle database, Oracle 23c database. And the first thing that we're going to do is we're going to reverse engineer from a DDL file. I'm going to grab that DDL file from a directory that I've already created over here. Right, so it's essentially the same thing that you saw earlier. We're going to open this and we're going to create this as tables in the ERD, which is the car demo ERD that we're going to be creating here. Let's enable our lineage capabilities, and after a few seconds you will see that it will create a model for me. Now you will see that the model is actually containing multiple things, right? So we have our tables over there and we have our duality views over there. You can see that these are located quite differently. You know, you can see that there's the dotted line over here. You can also see that in the race, the duality view, we actually have a very simple structure here, which is the blob, the podium blob. The podium blob doesn't give me any additional information about what this is actually going to be like. You know, it doesn't tell me anything about the structure of the data. And I'll show you how you can actually see more of this a little bit later on. But already it's probably useful to take a look at the DDL that we have over here, right, where you will have the duality view defined over there. All of this is now part of our Hackalate model. And I can edit this, I can play around with this, I can do multiple things here. This is yet another Oracle model. But why don't I take a look at the alternative way of creating this, which is not by inspecting the DDL, but by reverse engineering a target. Right? So I actually have an Oracle 23c instance running inside our Azure cloud. Right? So I'm going to say, let's reverse engineer this. Let's see if I have connectivity there. Yes, I do. Let's connect to it, and then I'll be able to select which specific part of this Oracle database server I want to reverse engineer. It's actually this one that I want. You see over here that I have drivers, but I also have some views here. So I can actually reverse engineer all of these tables, including the views, automatically. And what's interesting here is that I'm not just going to have the high-level structure that we saw earlier inside our DDL-based data model, but we're actually going to do some inspection here, right? We're going to do some probabilistic inferencing, where we basically create a schema for each and every one of these JSON duality views that we have inside this database server, and we're going to have a lot more information, right? So over here, now I see that the podium based on the sampling, has actually been refined and says, okay, there's actually multiple pieces of data inside this podium object. So this is really useful, right? Accolade is now not only giving me the high-level structure, but it's also giving me the detail underneath that. Now, maybe it's useful to just show you how you can create one of these duality views over there. So let's do that here. I'll add a view over there. This is a test view. And I'm going to indicate that this is a duality view from a particular route table. Let's say that this is from the driver table. I can add some table tags here, like this. And now I can start adding attributes to this new view that we have now. It's over there. Let's move that over here. I can say, okay, why don't we add a column here that we're going to pick from the field list of the route table that we are linking to. And now I already have these things added to my structure. The last thing I'd like to show you here is how you can actually have a little bit more of complicated attribute added to a view like this. I won't do that in this new test view, but let's take a look at this one over here, right? Where we actually have a nested structure of attributes that has been added to this duality view in our data model. And what you can see over there is that this is actually something that is going to be running a subquery, right? And this subquery is an array subquery that is going to get data from a child table, the drive race map table, which we call the DRM, and it is going to ensure that the race ID of the DRM is equal to the race ID of the race itself, right? So this is actually a query that is populating this array. Similarly, over there, you have an unnested structure object that is going to be doing something similar. It's going to pull the driver ID from the driver table and from the DRM mapping, right? So we have examples like this everywhere, right? So over here as well, you are actually running subqueries to create nested structures inside your data model. Last but not least, I'd like to highlight that Accolade obviously also generates the DDL for all of these artifacts, right? So this is something that you can then discuss again with your technical staff, your DevOps staff, and see how they can push this back into their live systems if appropriate. Right? With that, I'm going to wrap up this little demo and also wrap up this tutorial. I'll leave you with some reading material, both our online documentation, our blog, our socials, and obviously download the Accolade Studio for free. It's probably the best link that I can give you. And also I'd like to point you to a few books that have been recently published or are in the process of being published, among which the MongoDB book that was one of the first, and then the Neo4j, Oracle 23c specifically, available for pre-order at this time, Elasticsearch, and there are more coming in the next couple of months. With that, I'm wrapping up this tutorial. Thank you for your attention, and I wish you a wonderful rest of your day.